Combinations and permutations. When you're working with combinations and permutations, you'll be looking at what's called a fundamental counting principle. And what that is a method for finding a number, the number of possible outcomes. So this box here, this definition says if there are m ways to choose a first item and n ways to choose a second item after the first item has been chosen, then there are m times n ways to choose both items. So, for example, if you had apples and bananas, maybe your first item you choose is an apple, and after that, the other item you're going to choose is bananas. So you would take your m apples times your bananas. That's how many items you have to choose for between the two. So we're going to do an example of fundamental counting principle, and it says here a voicemail system password is one letter followed by a 3-digit number that is less than 600. How many different voicemail passwords are there possible? So what you're going to do is we're going to use the fundamental counting principle for this. And we look and see, so one letter followed by 3 digits less than 600. So how many letters are there in the alphabet? There are 26 letters in the alphabet. And then a 3-digit number less than 600. So we take our 26 letters of the alphabet times your 600, so it's 600 or less, which is 000 to 599. When you multiply that, it's going to give you 15,600. So the answer to that is there are 15,600 possible combinations of letters and numbers that you can create a password for your voicemail. Here are some definitions working with combinations and permutations. Please write all this down. A compound event consists of 2 or more simple events, such as a rolled number cube landing with 3 showing and a coin tossed that lands up. For some compound events, the order in which the simple events occurred is important. So you're given situations, the way a cube is rolled, the way the coin lands, that's working with compound events. And sometimes the order in which those events occur affects the answer. So what you have here is a combination, and that is grouping of outcomes in which the order does not matter. So you have different outcomes where the order does not matter. There is a formula for combinations that I will show you here in a little bit. There's also what's called permutation, and that is an arrangement of outcomes which the order does matter. So again, we'll do an example of a permutation also. Combination, order does not matter. That's what you need to know. Permutation, order does matter. So we're going to look at 2 examples, and we're going to determine if it's a combination or a permutation, and then give the possible number of outcomes. So Ingrid is stringing 3 different types of beads in a bracelet. How many ways can she sew 1 bead of each type to string to the next 3 beads? So for this, we're going to write down all the different designs of the beads. So the order of outcomes is important because this represents permutations. There's 6 different ways that the beads can be strung. So maybe you had a red, a green, a blue. So these are all the different outcomes. You have red, green, blue, red, blue, red, green, blue, green, blue, red, blue, green, red. These are all the different outcomes you could have for those beads. So that's a permutation. Order does matter. There's 6 different ways the beads can be strung. Nathan wants to order a sandwich with 2 of the following ingredients: mushrooms, eggplant, tomato, and avocado. How many different sandwiches can Nathan choose from? So you're going to list them all together in groupings. So again, he wants 2 of the following ingredients. So he could have mushroom and eggplant, mushroom and tomato, mushroom and avocado. He could have eggplant and tomato, eggplant and avocado, or tomato and avocado. Those are all the possible outcomes of the 2 ingredients he could have. So it says the order of the outcome is not important for this situation, so it is a combination. So how many different situations are there? There are 6. So 6 different ways to create a sandwich with that given information. Here's permutation. There is a formula for permutation, and the formula for this is the number of permutations of n things chosen are at a time. So we have n, number chosen, permutation r, that is chosen rate at a time. So what you have here is n exclamation. For instance, that exclamation means, like if you had 3 exclamation, that means 3 times 2 times 1. Okay, so that's the exclamation is representing counting down. All over n minus r exclamation. So here we have an example. A club was chosen, a president, a vice president, and a secretary from a list of 8 people. How many different ways can the club choose the 3 officers? So the position that each person takes matter. So this situation involves a permutation. So think that there are 8 people, and the club will choose 3 of them. So my n, my number of things, are going to be my 8 people at what are at a time, 3 of them at a time. So we have 8 exclamation over 8 minus 3 exclamation. 8 minus 3 is 5. So we have 8 exclamation over 5 exclamation, which gives me 336. How did they get that? Well, what they did is they did 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. 5 over 5 cancels, 4 over 4 cancels, 3 over 3 cancels, 2 over 2, 1 over 1. They all cancel out, so what you're really left with is 8 times 7 times 6, which gives me 336 for my answer. So let's look at another example here. It says, Lee brings 7 CDs numbered 1 to 7 to a party. How many different ways can he choose the first 4 CDs to play? So the formula you're going to use for this, it is a permutation. With the form of n p r equals n exclamation over n minus r exclamation. My n is my number. My number is going to be 7. 7 CDs numbered. And my r is going to be the amount of CDs, which is 4 CDs. So the way you'd set this up is 7p4, 7 exclamation over 7 minus 4 exclamation equals 7 over 3. So the way we break that down is 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. 3, 2, and 1s, they cancel. So what you're left is 7 times 6 times 5 times 4 gives you 840. So there are 840 different ways Lee can choose to play the 4 CDs. Now we're going to get into combinations. So the combination formula is a little bit different than the permutation formula. For the combination formula, the number of combinations of n things chosen are at a time. So we have n CR equals n exclamation over r exclamation parentheses n minus r parentheses or exclamation. So let's look at an example for this. We have a club will form a 3-person committee from a list of 8 people. How many ways can the club choose the 3 people? So what we have here is the position that each person takes does not matter. So this situation involves combinations. Think there are 8 people and the club will choose 3 of them. My 8 is my things, which is my people, my 8 people, and 3-person committee is going to be chosen at a time. So what I have here is 8 over 8 is my n. Then we have r, which is 3, exclamation, parenthesis, n minus r, so 8 minus 3, exclamation. So we have 8 exclamation on the top over 8 minus 3 is 5, so we have 3 exclamation times 5 exclamation equals 56. So let's do an example of this for a combination. It says a basketball team has 12 members who can play any position. How many different ways can the coach choose 5 starting players? So again, this is a combination. The formula for a combination is NCR equals n exclamation over r exclamation parenthesis n minus r exclamation. My n here is going to equal my 12 members, and at which rate in order, so my r is going to be my 5 starting players. So using this formula in my r and my n, we would use the formula for combinations. 12 is n, 5 is r. So what we have here is 12C5, 12 exclamation over 5 exclamation time, in parentheses, 12 minus 5 exclamation. 12 minus 5 is 7. So what we're left with is 12 exclamation over 5 exclamation times 7 exclamation. So look at how this is set up. Notice we did 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All over, you do your 5 exclamation, 5 times 4 times 3 times 2 times 1 times your 7 exclamation, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. Then you cross off what's in common, the 7s, 6, 5, 4, 3, 2, 1. So what I'm left with is 12 times 11 times 10 times 9 times 8, which is 95,040 over 5 times 4 times 3 times 2 times 1, which equals 120. So 95,040 over 120 equals 792. So there are 792 combinations for these players on the basketball team. So that is it for combinations, permutations. Let me know if you have any questions.